Once again, welcome back to Math 7. Today we're in section 5 of chapter 5, 5.5. We're going to solve two-step equations. So, solving two-step equations, a little trickier than the one-step equations we've been solving the last couple days. Let's take a look at this first example. 2x plus 10 equals 36. So, now we want to solve for the unknown x using our properties of equality to undo the operations. The question is, what shall we undo first? You know, there are many ways to transform an equation, and there's more than one correct way to do it. But there are some rules of thumb that make it, that reduce our errors. And so, as we look at this, we have multiplication of x and we have addition of 10. Which of these operations would be easier to undo first, do you think? And hopefully you're thinking that undoing the addition would be pretty easy. It's further away from the x. It's simple to do. All we have to do is, let's see if I can line it up, subtract 10. Now remember, what we do to one side, we've got to do to the other. So subtract 10 from both sides of the equation. And let's see if I can underline that. Good. And then we simplify. And so we would be left with 2x. These plus 10 and minus 10 are opposites, so they undo each other. 2x equals 36 minus 10 is 26. Good. And now we simply need to undo that multiplication, right? So let me do it this way. Let me underline that. And that underline is like our fraction bar, right? So we're going to divide both sides by what factor? Good, 2. So we're dividing both sides of the equal sign, both sides of the equation by 2, and our simplified expression, or simplified equation is x equals 26 divided by 2 is 13. Very good. So you can see that we undid the addition and subtraction, or we undid the addition before we undid the multiplication. Now, when we recall orders of operation, what's that little word we use for orders of operation? PEMDAS, right? So PEMDAS, P-E-M-D-A-S. We kind of remember that if I know all of the, if I knew this unknown, x, I would multiply before I would add the 10, right? But when we're undoing the operations, a good strategy is to undo them in reverse PEMDAS order. Undo any addition or subtraction, and then undo any multiplication or division. So it's a reverse order. So when we're solving two-step equations, we'll isolate the variable by undoing the operations in reverse PEMDAS order. Okay, so there are other ways, but this is a great rule of thumb. It's a great strategy, and it really works. So, good one to use. Let's try solving a couple of other two-step equations. And pause the video, give it a try, see what you can do. Okay, good. Hopefully. Okay, so you added 3 to both sides of the equation. Remember to always perform the same operation to both sides of the equation to maintain equality, right? So we end up with 2x equals 5 plus 3 is 8. Good. And now how do we undo this multiplication? The division property of equality. Divide by 2, and we end up with nicely isolated x equals 8 over 2 is 4. Now don't forget, you can check your work by plugging it in, right? Plug it in. 2 times 4 is 8. 8 minus 3 equals 5. Yay! Checks out. It is correct. Good. Let's try another one. 5x plus 1 equals 26. The first operation to undo is the addition. Good. So subtract 1. The opposite of addition is subtraction. Subtract 1 from both sides, and we are left with 5x equals 25. Whoopsie. crazy thing. 25. And now to isolate the x, to undo that multiplication of 5, we will divide by 5. Good. And I'm sure you know the answer. The solution for x is 25 divided by 5 is 5. Good. And when we plug 5 in, we end up with 5 times 5, 25, plus 1 is 26. Yay, we got the answer. Good. We're going to try number 14 from the book because it is trickier. And what do you see here that is trickier? I hope you see that we are subtracting the variable term, which makes this a lot more challenging for students. When they see subtraction, most students think, I need to add, right? And they add, unfortunately, 20 to both sides. But look at 20 plus 20 would not remove the 20 from the left side. So if you're going to add something here, you would be adding what is being subtracted, right? Which is 6w. Okay, so that's interesting. That reminds us of the addition property of equality from a couple of days ago. When we had a negative variable, we added it to both sides, didn't we? Now when I add 6w to the right side, 14 doesn't have any w's. So these are not like terms, 14 and 6w. They're unlike terms. So we just leave them separate. 6w plus 14 on the right side equals 20 on the left side, right? We got 20 way over there. Okay, so now the benefit of that is we now have a positive variable term. It was negative 6w's, now I have positive 6w's. So now I can just isolate the w like we have been doing, right? So what would we undo first now? The addition, right? So undo that by adding 14 to both sides. Adding 14 to both sides. And we end up with 34 equals 6w. Oh, goodness, I added. I should have subtracted. I'm sorry. Let's make that a negative. Let's go back and erase that. I'm sure you all caught that before I did. Good. And we have 6, right? 20 minus 14 is 6. 6 equals 6w. Much easier expression or equation to solve, right? When we divide by 6, we end up with w equals 6 over 6 is 1. Good. W equals 1. I wish I had a better stylus for this, a touch screen, but that's in my future. So let's try this in this solution in the original equation, the solution of 1, right? Plug in a 1 up here, and we have 20 minus 6 times 1, 20 minus 6, that is equal to 14. So we know we have the correct answer. Yay. Okay, so be careful when you have a negative or you're subtracting the variable term. I think this can be very tricky there. And this strategy is to add the negative variable to both sides, then solve. That helps. Okay. And go ahead and try this equation. Another negative variable, see what you can do. And come on back and test out. See if your answer is correct. Okay, if you added two d's to both sides of this equation, you then ended up with something like this. 24 equals 2d plus 36. Remember, 36 and 2d are unlike terms, right? Okay, so we cannot combine them. Good. So then you probably subtracted 36 from both sides. Good. And when you did, you're getting that d more isolated, right? Over here, the 36 is gone. So we have 2d on the right side. And on the left side, 24 minus 36. Ooh, that's really negative. That's negative 12. Good. And now, in order to get d completely isolated, we divide by 2. Divide by 2. And you end up with negative 6 equals D, right? Because 2 over 2 equals 1D. Very good, negative 6. So when you plug that into the original equation, 2 times negative 6 is negative 12, and negative 12 plus 36 is 24. So this is correct. I'd like to show you another way to transform this equation. That would be to leave the negative variable on the left. Okay, so remember, subtraction is just addition of the negative, right? Addition of the opposite. So if we wanted to, we could leave that term on the left. In that case, we need to get rid of the 24. So what is the inverse of a positive 24? It's a negative 24, right? So carefully move the 24 away from the left side by subtracting it. When we do, you can see that we have negative 2D. Bring that negative with you. Don't lose it. Negative 2D equals 12, right? Good. And so now in order to isolate that D, what are we going to divide by? The entire negative 2. Good. Negative 2. And when we do, ta-da, we end up with 1D equals negative 6. Hey, so this is a little trickier way to transform the equation and solve for D. And just remember to keep your negative variable negative, right? And when you're removing a positive, subtract it. Okay? Very good. And you're ready to begin. Here is your assignment. And there will be a quick quiz on the first 4 sections in our next class. So be prepared. You might want to look over your concept book. Study a little bit for that. Okay? Have fun.